Welcome to this video lecture. My name is Mark Scythian. The date today is January 8th, 2023. And if you're running into a problem computing Pitot-Static, Mach number, and true airspeed, as well as calibrated indicated airspeed, stay tuned for this lecture. So assume that we have a Pitot-Static application on a Boeing 737 and the pitot ram air pressure at 8 kilometers above mean sea level is recorded at 14.765 inches of mercury. We can divide that value into 2.036 to compute 7.25 psi, and then multiply that value times the ratio of 101.353 pascals at sea level divided into 14.7 to compute 50,000 pascals of pressure for the stagnation pressure at the Pitot Tube. Okay, so next we got to compute the atmospheric pressure at 8,000 meters or 8 kilometers above mean sea level. So we can convert that to feet. Pressure altitude, which is 26,240 feet. And then we can use this equation here to compute the atmospheric pressure in psi between 0 feet mean sea level and 36,089 feet MSL only. And then this computes to 5.17 pounds per square inch atmospheric pressure. We multiply that times 101.353 divided into 14.7. So we compute 35,646 pascals of atmospheric pressure. Then we can run it through this equation as listed here. So we're doing the isentropic exponents with respect to the ratio between the pitot pressure and the static atmospheric pressure. So when we work this out by applying the rules for exponential computations, we can take 1 over the 3.5 power to cancel the 3.5 power on the right side. And so when we work out this iteration, we compute a Mach number of 0.71 and assume that we are flying through some strangely higher air temperature, like 300 degrees Kelvin. We can subtract 273.15 from that value to compute 26.85 degrees Celsius, and then multiply it times 9, divide it by 5, add 32 to compute 80.33 degrees Fahrenheit. We add that to 460. This then computes the Rankine's absolute air temperature of 540.33 Rankines. Then we find its square root times 49.022 to compute the speed of sound at 80.33 degrees Fahrenheit of 1139.5 feet per second. We can then multiply that times the Mach number of 0.71, so we compute a true airspeed of 809.06 feet per second, which is then converted to meters per second unit, so it's 246.7 meters per second. So the true airspeed with this with these metrics of 8 kilometers pressure altitude, 300 degrees Kelvin air temperature, and then we have a 14.765 inches of mercury Hg in the pitot tube, and then we have to solve for the static tube so we can get Pitot-Static together. And so based on those values, the true airspeed is at 246.7 meters per second, or a Mach number of 0.71. So the next thing we have to do is then compute the calibrated indicated airspeed. So we can take the 517 pounds per square inch atmospheric pressure and multiply that times 144 square inches to a square foot. So we got to convert it to pounds per square foot, sorry. And so we still have a pressure value, but it's pounds per square foot. And then after that, we then enter it back into our isentropic Mach number equation, and we compute 1.3996 as the coefficient. We multiply this times the atmospheric pressure in pounds per square foot. And then from that point on, we can compute the mean sea level standard air density in slugs per cubic foot. So that's just the pounds per cubic foot times 1 over 32.2. So 0.002373 slugs per cubic foot. And then lastly, we access the VCal Inc. equation to compute calibrated indicated airspeed, and that is 2 times the stagnation pressure subtracting the atmospheric pressure at sea level. And then we have then the pressure gradient based on the P sub O minus the P. So in this case, it would be the pressure gradient minus the atmospheric pressure in pounds per cubic foot. And then we actually can combine this with the absolute imperial units for air density slugs per cubic foot, because we derive that out of 1 over 32.2, and this then equates to a calibrated indicated airspeed equal to 500.7 feet per second, and this is then converted to meters per second. So 152.7 meters per second is the calibrated IASc indicated airspeed, equal to 152.7 meters per second.